explain the concept of binomial distribution and what it exactly means. I will try to be intuitive as much as I can, and you will have no option but to understand what is really happening here. I want to start this video with a simple question. Let's say we are throwing a dice 10 times. What is the probability of getting 3, let's say 6, okay, let's say 3, because I want a probability a bit higher. Getting 3 2s in 10 dice roll. That is the question. And let's break it down. Let's break this down into smaller problems. And let's start with what is the probability of getting 2 in one dice roll? It's very simple. It's simply 1 over 6, right? 1 over 6. Probability of getting 2 in one trial. Okay, now let's say what is the probability of getting 3 2s in a consecutive way. For example, we are throwing a dice 3 times and we're calculating the probability of getting 3 in each one of these events. So it will be simply, we will calculate it with the multiplication rule for finding the intersection of the probabilities. So we'll have 1 over 6 multiplied by 1 over 6 multiplied by 1 over 6. Why are we multiplying it? Because we already know that these events are disjoint. So they're independent, and the joint probability of independent events is just the multiplication of their individual probabilities happening. So this will be the probability of getting 3 2s in 3 dice roll in a consecutive way. Actually, the order doesn't matter, but if we just get 3 dice roll, so it will be a consecutive. So now let's say let's make it a little bit complex. We're saying what is the probability of getting 3 2s in 10 dice roll. This is just, as you know, we're getting closer to the original question, but we're not here exactly. So let's say then we have 10. We have 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we will have 10 events. They are disjoint, they are independent. And we're saying what is the probability of getting 2 3 times. So still it will be 3 times. And let's say right now it happened 1 over 6, 1 over 6, and 1 over 6. So right now, this is the probability that we'll get 2 3 times. 3 times. So if we get it 3 times, and I want to make a very important distinction here. We're not saying at least what's the probability of getting two at least three times. We're only interested in what is the probability of getting two exactly three times. So if we're gonna get two exactly three times, then the remaining seven times we shouldn't get two. We shouldn't get two. So what is the probability? Uh, so we're only interested in this part, right? Because we had our three uh, trials and we got those. We got two, and we have left with seven trials, and exactly on those seven trials we should not get two. So in one event we have to calculate the probability of not getting two, right? It will be the same for every one of them. Yeah. So this is the probability of getting two three times in 10 dice roll, and it's just a multiplication of all of these probabilities, and seven times we shouldn't get two. We multiply those probabilities, and three times we should get two. No, the seven times we shouldn't get two, we multiply the probabilities of not getting two seven times, and we have three, and we multiply the probability of getting two three times. Okay, then we can simplify it as 1 over 6 to the power of 3 multiplied by 5 over 6 to the power of 7. So, do you think that it's really the probability of getting two heads in 10 dice roll? Actually, no. Actually, no. We only calculated the probability of getting two in our three first trial. Only in three first trial. And that is that probability. But we're not only interested in that, we're interested in what is the probability of getting two three times in any way in 10 dice roll, in any way. That is the key. So if we're calculating in any way, we have to calculate the possible number of ways that we can get three twos. And how do we do it? We just simply use this formula, and we use it as the number of ways choosing 3 out of 10. Okay, I will calculate it, then I will show you how it is relating to our answer. So it will be 1, 3, 2 divided by 1, 2, 3. And we'll get these, and we are left with the answer 10. And simply we multiply this probability by 10. Why are we multiplying it by the 10? Because, for example, let's say the 10 is not here. The 10 is not here. We just want to do it without the 10. So we have this probability, and this is only the probability of getting 2 in the first 3 trials. And this probability is can happen, and then we add it with the probability of getting 3 twos in, for example, in some different way, and it goes like this: 1, 2. Why we are adding it? Because they don't happen at the same time. We're saying what is the probability at the end? What is the probability of getting 2 3 times in the first 3 trials, or what is the probability of getting twos in the first, not in the first, for example, in the second third and the fourth trials consecutively. So these are different events and they all contribute to the overall probability. That's why we are adding them. So how many times we will add them? We will just add them simply the number of possible times that we can, the number of possible ways that we can get 3 out of 10. So instead of just writing it at like adding it 10 times, we are just multiplying it by the number of ways that we can choose 3 out of 10. And it's just this. At least this part. Okay. And we start to see a pattern here. And let's say we have 3, n is 3 and k is 10. K is the number of trials and n is the number of times the probability of n times that we're interested in. For example, in this case, we're interested in probability of getting 3 times. And now the n is 3. So as you can see, we can just simply write it as C. It's just C means a combinatoric C10 CK and the number of possible ways of choosing n out of k multiplied by the probability of getting that event in one trial. It's simply P over n multiplied by 1 minus P. You can say this is 1 minus P. K minus n. Okay, we calculated this probability. And let's see how it relates to distribution. Okay, distribution. Let's say we have a random variable x. And this x can take any value. For example, let's say we throw a coin n number of times, and what is the probability of getting it k times, right? So it can be, for example, let's say this is 10 times, and this x can range from 1 and 10. It can take any value between 1 and 10, and we write it as 1, 2, 3, 4, 5, 6, 7. So now let's look at 1. Then how do we calculate this? We calculate the probability of getting 2 once out of 10 dice roll, and we'll calculate it by this probability, and let's say it will be something like this. Then 2 times will be something like this. It will be something like this, this. Okay, like this. So this is a binomial distribution. And what are these? It's just simply this formula. We calculate this with this formula here. Okay, let's copy. Okay, paste. Calculate all of these with this formula. Yeah, and like this for all of those. So this is simply a binomial distribution, and as you can see, this is a discrete um, set, discrete distribution, binomial distribution, and the random variable. Oh, the being a discrete isn't about the distribution. This random variable is discrete. Why? Because not only that the range is between 1 and 2, because in that case x can take any value between 1 and 2. The number of values that x can take between 1 and 10 is infinite. The key here is that we can count the possible number of values between 1 and 10 in this case. Because, for example, what is the probability of getting 2 one time? What is the probability of getting 2 in 2 times? What is the probability of getting 2 3 times? What is the probability of getting 4 of getting 2 4 times, 5 times, 6 times, 7 times out of 10 dice roll? So that's why this is purely a discrete random variable.